two aspects now. Big data, I said, it's not only for the new and fancy stuff, it's also for the things that maybe make up now 80 or 90% today of the data foundation of decision making. That's the structured data. So we see that some technology advancements are refining the way how to work with structured data. And basically we talk about analytical databases here as one of these advancements. And you can track down these developments all to the east coast of the US. So about 10 years ago, there has been a big startup surge on the east coast. Basically what we could see is that after about 10 years of data warehousing, the concept of the relational database was definitely at its end. It's now very obvious that this is the wrong technology for a lot of challenges and a lot of requirements we have for data warehousing. And we could also see that the big vendors were pretty slow in moving, were pretty slow in innovating. Basically they did nothing. They were protecting a very nice high-margin business they had. That was using relational databases and tuning it, turning it into making it somehow useful for data warehousing and analytics. But we could see with the rising challenges, this basically came to an end. And more companies said this is not going forward this way. It's too costly, too much maintenance. It's simply too complicated to maintain data warehouses with this type of database technology. So there was a big surge in upstarts, in startups. And basically there were mostly East Coast US companies. The oldest vendor in that segment, Teradata, came from the East Coast, and all the startups like Greenplum, NetTeaser, Vertica, 1010 Data, and so on and so on. Basically all came around the Boston area where the North American database community is located. So what was happening? We were looking at more flexible ways and new ways to store data, to provide data for analytics. And it's basically a look at three different dimensions. And from our point of view, it's really important to see that it's three different dimensions, because many vendors often only pick one of these to describe what they're doing. But that's only a limited description, it's only a limited picture, because it's important to see what's actually happening. So we see changes and innovations in three areas. One is how data is stored. And what is absolutely accepted today, what was something new, not new from a technology side, but new from a perspective that it's actually usable in a broader scale, is the columnar database. So that the classical row-oriented data stores were changed in a way to organize data in columns. And especially for BI applications, this can be very beneficial. In query response times usually, and it has a nice, very nice side effect that in columns you usually can compress data much better. So you can compress it, so the problem of growing data volumes is actually could actually be tackled much better with compression. If you take in the next step, that you can also work, like process compressed data. So you have the processors working on a reduced data volume. You could also even tackle the problem of the analytical complexity, because you could make not only better use of the storage of the disk and RAM space you have, but you could also make use of the processors even better. So it proved to be quite a beneficial technology, and today is absolutely accepted. Even the large vendors that for many years defended their row-oriented approach and always said, well, this is like obscure stuff, you should never look at it, stick with the traditional, solid row technology. They all said by now, okay, it's totally right, this is a beneficial concept, and we start to employ it also. So what you see today is a lot of hybrid databases that give you the option to either store row or column oriented, but there's still some specialists in the market who often do it better because they are much more concentrated on the specific technology. Second thing we could notice is that the physical hardware place where data is stored is changing with Moore's laws. I dwelled into that last year in this keynote a little bit. So it's basically a trend you can all notice, and especially in Germany with SAP being very prominent. Obviously, we all know about the concept of a memory database, and since we look at it for some time now, I think everyone knows about the benefits, but also the limitations it obviously has in cost and in size that you can actually store. But the trend is there, it's pretty clear. Main memory gets cheaper, so you still have Moore's law valid, you have still the doubling in capacity for the same price every 2 years, and we see now that a lot of the sizes we have in data warehouses, in the smaller and maybe even in the medium-sized field, will fit into main memory. So for these sizes, this could actually be an interesting option to take a look. And we see some startups around that. Again, like SAP developed a new database and other companies also, and they were looking at ways to store data for faster access. That's the core idea. So it's really query performance at the core of what they wanted to do here. And what we see with all vendors is basically the concepts where to store data and how to store data are redefined with the need to put more data into main memory and the need to be able to access data faster to actually handle the performance requirements by users. And the third dimension would be how a database is provided. And about 10 years ago, we saw these startups of beginning of appliances coming more vastly into the market. Appliances are hardware-software combinations, so basically you buy a box with a pre-installed set of software. And this turned out to be pretty useful, pretty beneficial. So today, we see that most vendors actually offer appliances and often also software on the side. And what's pretty new, what's coming more and more, but what is more popular in North America, much more popular than here in Europe, is the whole topic of hosted databases, software as a service, in the cloud, however you would call it. And there are actually different methods and different ways to offer that. But in the end, we see reports today that US-based software vendors in data management and BI already see quotas of about 50 to 80% of their business being made in hosted solutions, in whatever form, even real software as a service or simply hosted, whatever. So obviously in North America there's an extremely big demand from companies that simply say we don't want to host this anymore. This is not our business. This is software, it has to be running, but we want to access it and use it and not handle the whole thing. In Europe, especially in Germany, same companies, same software solutions. North America, 80% hosted business. Germany, take a guess. 0. Totally not in favor here, for whatever reasons, mostly cited security, but I'm pretty sure this will change. The advantages companies have are pretty big. The problems they have with running the system themselves are also pretty big. So I'm pretty sure this shift will happen. Maybe not this year, maybe not next year. We will all keep quiet a little bit and see how things are advancing. But the advantages, the benefits are pretty big. So I think in the end we will end there also. So most vendors that we see now recognize this and say, okay, there's a need for flexibility here. There are still lots of companies out there that want to install and run their own software. So they provide software. Other companies say, okay, this concept of an appliance has some limitations and flexibility, but on the other hand, we have a big benefit in maintaining and installing this system. So we want to have an appliance. Okay, so they offer appliances. And more software vendors add a third concept to that, a third distribution method that would be to have some kind of data as a service, software as a service, hosted solutions in a public cloud, hosted individual, whatever, just to get rid of the effort to maintain these systems in the companies. If we would put these on a layered model that you probably all know, looking at the layers you look at usually in analytical architectures, coming from the applications, accessing data, we see analytics moving more and more closer to the data itself. So we often see this kind of analytics layer on top of the storage itself. And then the data integration, these analytical databases well fit in and often replace or complement existing technology there. Often starting with the notion of a data mart, usually more for analytics, but we see more and more of these data marts growing and actually starting to replace more and more layers of the data awareness also. So the common set of features would be that it's optimized for analytics, so it's very clearly not usable for transactional system. It's usually a massively parallel architecture, so the MPP architecture is absolutely dominant here. It's columnar or hybrid from the storage structure. It's often in memory databases or other databases make more use of SSDs instead of disks. And for the big data warehouses today, it's a mixture of all. Some part of the data will be in memory, some on fast drives, and some on slower drives that can pick up the volume. And then we have often appliances in this field, because this actually has been a distribution method that's now pretty well accepted, very successful in the market also, so we can see that. The second technology on the structured side of data would be streaming databases. This is a term that's evolving right now. We talked about complex event processing or event processing for some years now. But there seems to be a growing need for looking at data on the move. So it's not about now storing data, creating a historical profile of data, but it's basically looking at data that's on the move and that is often consisting of events or sensor data that's coming in very high volumes. And we have to tackle the need of, first of all, being able to take this data in. Comes in very quickly in extremely high volumes, and then what we do with it is basically a monitoring operation. So we don't want to build any fancy report out of that, but we want to have a look at this data and see whether we can find interesting things. So what we need is models or patterns or rules to be able to monitor this data and actually find out what's interesting. But again, it's a notion that we get closer to the actual data production, we get closer to the operational systems to be able to get more insight in what's happening in the processes today. And with that, we see in more and more industries the needs and demands coming up for this specific part.